Okay, so this is example 12.1 that I did in class. Now that I learned how to record myself, I'm going to redo it. So the first thing I'm going to do is I'm going to highlight some of the important information in the given. So the car on the left in the photo and in figure 12 moves in a straight line, so that's important, straight line, such that for a short time its velocity is defined by this equation here, so that's important, this equation for the velocity. Determines its position and acceleration when t equals 3 seconds. Okay, so we want to know where it is and what the acceleration when t is 3 seconds. And then finally do this when, when t equals 0, s equals 0. So there's some initial conditions there. So let's write this all out in given, required, and find. So given, let me make the pencil a little thicker there. We'll do that. Okay, so given, we know the velocity is given by this equation, 3t squared plus 2t in feet per second. Let me make that all a little, that's too fat now. Let's get it a little thinner. Let's try this one. Okay, so given, the velocity is given by this equation here in feet per second. We also know that when t equals 0, s equals 0, so that's called the initial displacement, s sub 0. Okay, and so that's it. So required, they want us to find the position and the acceleration when t equals 3 seconds. So solution. So you look at this equation and it's in terms of v and time. So we want to use an acceleration, so we probably want to use this one. A equals dv dt. So that's straightforward. So a equals the derivative of t, so that's 6t plus 2. And so a at 3 seconds is 20. Okay, feet per second squared are the units. Feet per second is velocity, and velocity per time is feet per second squared. We need to get the displacement. What do we know about the displacement and velocity? Well, we know that the velocity is ds dt. So we're going to plug in the equation for velocity. So 3t squared plus 2t equals ds over dt. And from your differential equations class, you separate the variables. You put all the s's on one side and all the t's on the other side. So we have 3t squared plus 2t dt equals ds. We're going to integrate both sides. So we're going to start at 0, go up to 3 seconds. 3t squared plus 2t dt, okay, equals the integral from s0 to s at 3 seconds ds. Okay, so the integral of 3t squared happens to be t cubed, and the integral of 2t is t squared. We're going to evaluate that from 0 to 3. The integral of ds is just s from s0 to s. So we have 3 cubed plus 3 squared equals s minus s0. And you look up here and you see that s0 is 0. So s. And so s at 3 seconds equals 27 plus 9 equals 36 feet. And I would like you, when you do these problems, to put your final answer in the box. And I prefer sentences. So at t equals 3 seconds, okay, s equals 36 feet, and the acceleration equals 20 feet per second squared. And it'd be very nice if you box that. There we go. And so I can make fancy straight boxes using this software, and there we go. So that's it.